Trial version. Trial version. Trial version. Trial version.
Parabola, very good. Astran, I think Astran said this. Parabola. Yes, it will be a parabola. And in case beta is
Trial
less
version.
than alpha, then
Hyperbola.
hyperbola. Are you guessing it? Because circle is ruled out, parabola ruled
Trial
out,
version.
ellipse ruled out. The only case left is hyperbola. Now we'll have a look.
Trial
So if
version.
beta is 90 degree, it is a circle. If beta is less than 90 but more than alpha, it is an ellipse. If beta is equal to alpha, it's a parabola.
Trial version.
In each case, the plane cuts entirely across one nap, just one nap.
Trial version.
Case A, case B, and case C, the plane cuts one nap, one of the two naps. But when beta is greater
Trial
than
version.
0 but less than alpha, then this plane will cut both the naps and you will get a hyperbola. Have a look at the diagrams.
Trial version.
That we couldn't understand. Man.
Which one? Beta? Beta equal to alpha?
Yes, sir. I mean,
I'll show you the diagram. I'll show you the diagram.
Trial version.
First diagram. Beta is 90 degree and you get a circle. Now you can understand.
Trial version.
Second diagram. Beta is less than 90 but more than alpha and you get an ellipse. You can visualize now.
Trial version.
yes, sir.
Okay. Here you are. Beta is equal to alpha and you get a parabola.
Trial
Oh, yes,
version.
I understand.
Understood? And in the fourth case, beta is less than alpha and it cuts both the naps and you get
Trial version.
a hyperbola.
Yes, sir.
Clear? Absolutely.
Sir.
Okay.
Trial version.
Now tell me what happens if the plane passes through the vertex in all the four cases.
Trial version.
Imagine there's a feedback noise. I think Astran.
Is it a straight
Trial
line?
version.
Not always. You have to tell me in which case it will be a straight line. Imagine the plane is always passing through the vertex. Now by changing the angle,
Trial
you get
version.
different cases. Can you explain the different cases? Imagine the plane is always passing through the
Trial
vertex.
version.
Say case 1, I mean 11.4. When you get a circle otherwise, okay, the plane is perpendicular to the axis and
Trial
you
version.
get a circle. Now bring it down to the vertex. The radius of the circle will become smaller and smaller and smaller.
Trial version.
And ultimately when the plane passes through the vertex, what do you get?
Point.
A point. Correct. Now, is it
Trial
only
version.
for beta equal to 90 or some other cases also? Will you get a point only
Trial
when beta
version.
equal to 90 and the plane passing through the vertex? Or there are some other cases also?
When beta is more than alpha, will be always
Trial version.
Beta is a lot of noise. Lot of noise. Yes, can someone else tell me?
Trial version.
Astran said something I couldn't understand. In which cases it will be a circle, it will be a point.
Trial version.
As long as beta is more than alpha.
Trial version.
Think about it. Beta is more than alpha,
Trial version.
less or equal to 90. When beta is equal to alpha and the plane is passing through the vertex, what do you get?
Trial version.
Straight line.
Straight line.
Yes, sir.
And that is a degenerated case of
Trial
a
version.
parabola. Okay, beta is less than alpha and the plane is passing through the vertex. What do you get?
Trial version.
Plane is passing through the vertex. Beta is less than alpha.
Parabola and
version.
hyperbola.
Not clear. You said something I couldn't understand.
Trial version.
We will get a pair of straight lines, and that is a degenerated case of hyperbola. So whenever the plane is passing through the vertex, we get a degenerated circle, degenerated parabola, degenerated hyperbola. So the degenerated
version.
conic, it means the plane is passing through the vertex. When beta is more than alpha but less than 90, we get a point.
Trial
When
version.
beta is equal to alpha, we get a straight line. It contains only one generator line. It's a straight line.
Trial version.
So that is a degenerated case of a parabola, because otherwise this would have been a parabola. When beta is less than alpha
Trial
and
version.
more than 0, obviously, we get a pair of straight lines, and that is a degenerated case of a hyperbola. So you see how many cases are there.
Trial version.
From the double cone, a double napped cone, from the sections of the double napped cone, we get number one, we started with circle. Then we
Trial
saw that
version.
we may also get a parabola, ellipse, hyperbola, a point circle, a straight line, a pair of straight lines.
Trial version.
So many different sections. Now we'll go to the analytical part of it, mathematical part of it. And how do you frame the equations?
version.
We take the cases one by one. Okay. Conic sections. Generally, we'll discuss the cases parabola, ellipse, and hyperbola. Circle is already
Trial
discussed.
version.
So now it is clear that circle is actually a conic section, isn't it?
Yes, sir.
So these are the
Trial
degenerate
version.
cases, diagrams. Very nicely drawn.
So can I show the diagrams once?
Yes, these diagrams, right?
Trial version.
Yes, sir.
First case, the plane is passing through the vertex and it is showing it is perpendicular, but
Trial version.
as long as it is more than alpha, you'll get a point.
Yes, sir.
And in the second case, beta is equal to alpha,
Trial
and you get
version.
only one straight line, and that is one of the generators. Then is it okay now?
Yes, sir.
Trial
Noted.
version.
Okay. In this case,
Trial version.
beta less than alpha, and you get a pair of straight lines.
Trial version.
Yes, sir.
Now we'll go to the mathematical part of a
Trial
parabola.
version.
Before that, before going to parabola, in
Trial
general,
version.
let me explain the property of this conic sections, parabola, ellipse, or hyperbola altogether.
Trial version. Trial version.
So imagine this is a straight
Trial
line.
version.
excuse me, and this line is fixed, and there's a point.
Trial version.
And this point is also fixed.
Trial version.
Now there's a variable point.
Trial version.
There's a variable point.
Trial version.
There are 2 points.
2 points. You can see there's a point. I'll
Yes, sir.
give it a name.
Trial version.
This is a fixed point S.
Trial version.
This is a fixed point.
Trial version. Trial version. Trial version.
This is a fixed straight line.
Trial version. Trial version. Trial version.
And there's a moving point P.
Trial version. Trial version. Trial version.
But the point is not moving freely. The point is moving in the plane, satisfying certain conditions. Now, what is that condition?
Trial version.
Wherever P goes, the distance between the fixed point and the moving point, that is PS,
Trial
and
version.
the perpendicular distance of the point P from the fixed line. I give it a name. Suppose the foot of the perpendicular is,
Trial version.
say, M. Okay. This is
Trial
perpendicular. So wherever P goes, the two distances, distance from the fixed point, that is PS, and the
Trial
perpendicular
version.
distance from the fixed straight line, PM, these two bear a constant ratio. So PS
Trial version.
upon PM
Trial version.
this is fixed. This is constant.
Trial version.
So P is moving, but P is moving
Trial
satisfying
version.
this condition that PS upon PM is always constant. This constant number may be a number more than 1, equal to 1, less than 1,
Trial
but it is
version.
constant. Depending on the value of this constant, it describes a particular conic section, a parabola or ellipse or hyperbola.
Trial version.
Suppose we give it name. The name of this constant is eccentricity, or some will say eccentricity.
Trial version.
So the name of this constant is
Root over 1
Trial
p square by a square.
Yes, that is for ellipse.
Yes, in physics we studied.
Yes.
Trial version.
I'm sorry.
Trial version.
So it is the name of this constant,
Trial version.
eccentricity. Okay. In short, we denote it by
Trial
the
version.
letter E, small e. It is not the constant e that we use in logarithm, not that e. Okay, this is different.
Trial
This is
version.
used only reserved for these conic sections. This e is eccentricity. So e is a fixed number. It is a fixed constant. If e is
Trial version.
equal to 1, if e is equal to 1, that means wherever p goes,
Trial
ps
version.
upon pm is equal to 1. Then the locus of p will be a parabola. So e is equal to 1 implies the locus of
Trial
p
version.
is a parabola.
Trial version. Trial version.
If e is less than 1, then the locus of p
Trial version.
is an ellipse.
Trial version.
And if e is
Trial
greater than
version.
1,
Hyperbola.
hyperbola. Very interesting chapter. This is
Trial
hyperbola.
version.
It is not hyperabola, it is hyperbola.
Trial version.
So we'll take up the cases
Trial
one by
version.
one. First, we'll consider the case e equal to 1, this case, parabola. So for a parabola, there's a fixed point S, there's
Trial
a fixed
version.
line, and there's a moving point P, which moves in such a way that PS upon PM is equal to 1,
Trial
is
version.
equal to E is equal to 1. So PS upon PM is equal to 1. That means PS is equal to PM. Okay. This fixed line
Trial version.
has a fixed name also. It is known as the focus of the conic section. So this is the focus.
Trial version.
Focus of parabola, focus of ellipse, focus of hyperbola. It is a focus. Every conic section has a focus, at least one focus. In case of parabola,
Trial
one
version.
focus. In case of ellipse and hyperbola, two foci. And the fixed straight line this also has a fixed name. This is
Trial
called
version.
a directrix or directrix as you pronounce it.
Trial version. Trial version.
Okay. The fixed point is focus. The fixed line is directrix. And
Trial
when you
version.
draw the focus, when you draw the parabola, this will look somewhat like this.
Trial version.
Like
Trial
this.
version.
So we'll take this case one by one. I'll show you one example of how exactly a parabola looks like.
Trial version.
When you draw a perpendicular through the fixed point
Trial
S, we
version.
draw a line perpendicular to the directrix.
Trial version.
This line will be the axis. My diagram is wrong actually, but the ellipse will be symmetric about this axis.
Trial
I'll show you
version.
the exact diagram. Just a minute.
Trial version.
That means it will pass through the vertex.
Yes. Just 1 minute.
Trial version. Trial version. Trial version. Trial version. Trial
So you can
version.
see
Yes, sir. The x
Trial
coordinate
version.
axis. The x-axis.
this is x-axis is the axis of the parabola. This point
Version.
This point at 1, 0.
Trial version.
It's not showing. Anyway, this 1, 0, this point will be the focus. Okay. And this line, x plus 1 equal to 0, is the directrix of this parabola.
Trial version.
The directrix will be. This is the
Trial
directrix.
version. Trial version.
This point is the focus. 1, 0. Here's the focus. I'll discuss it one by one. Through the
Trial
focus,
version.
you can draw any number of chords, right? You can
Yes.
draw many chords through the focus. Okay. Any chord that is
Trial
passing through the
version.
focus is called a focal chord. A focal chord. When the focal chord is perpendicular to the axis, it has a special name. It is
Trial
called
version.
a lattice rectum. So the lattice rectum is the line from this point to this point. I'll show you in the
Trial
diagram
version.
later.
That is 0, 2 to 0, minus
No,
2.
no. This will be 1, 2 to
Okay,
1, minus 2.
Trial
Yes.
version.
That line is called the lattice rectum. Okay. This is called this point of intersection of the
Trial version.
axis of the parabola and the parabola. The point of intersection of the axis and the parabola. This is called the vertex. So in this
Trial
case, the
version.
vertex is at the origin, 0, 0. So the vertex is at the origin. The focus is at 1, 0. The directrix here,
Trial version.
the fixed line, directrix is here, x plus 1 equal to 0, x equal to minus 1. And if you take any point on this, any point, you will see
Trial
that the
version.
distance of the point P from the focus, PS, and the distance of the point P from the fixed line, PM, will always be equal. I can
Trial
show you one
version.
example. Okay, number 1, 1, 0 to 0, 0. What is the distance? 1 unit. 0, 0 to this point.
Trial version.
That is also 1 unit. One example. Take another one. Consider this point. This point is 1, 2.
Trial version.
Why it is not? Anyway, this point is 1, 2. From this point 1, 2 to the
Trial
focus.
version.
distance is 2 units, and from the point 1 comma 2 to the directrix, if you count these blocks, you'll see that it is also 2
Trial
units. PS equal to PM. And you take any other point, anywhere, you take P anywhere, PS and
Trial
PM
version.
will be equal. Right? Let's go back.
Trial version.
How do you get the equations? Very quickly.
Trial version.
So this is that parabola. Fixed point focus. This is a fixed line directrix. And you take any points P1, P2, P3.
Trial
They are
version.
showing, explaining that the distance of the point from the focus and distance of the point from the directrix, they are equal. I hope you can understand from this
Trial
diagram
version.
that they are equal. P1F equal to P1B1, P2F equal to P2B2, P3F is equal to P3B3, and so on.
Trial version.
Because in case of parabola, E is equal to 1, so PS upon PM equal to 1. They have taken F instead of
Trial
S.
version.
I'm using the letter S, they are using the letter F. So in this case, PF upon PM, PF upon PB in this case, equal
Trial
to 1.
version.
So you may draw this diagram to understand different names. This is the focus. This line is the
Trial
axis.
version.
You can see that the parabola is symmetric about the axis. The point of intersection of the
Trial
parabola
version.
and the axis is known as the vertex. And the fixed line is called the directrix. Now, how do you get the equations?
Trial version.
What is the equation of this parabola? To understand the equation, you must have understood now that the distance of the focus from the vertex
Trial version.
and the distance of the vertex from the directrix, they are equal. These two distances must be equal, again by definition.
Yes, sir.
Okay,
Trial
1
version.
minute.
Trial version.
This distance
Trial version.
and this distance, they are equal. Suppose this distance is equal to A. Okay, we have to assume it. Based on this
Trial version.
measurement, if it is A, then we will define the equation of the parabola. We'll derive the equation of the parabola. So we
Trial
consider
version.
this distance, which is fixed for a parabola, distance between vertex and focus, or distance between vertex and directrix. Suppose it is equal to A.
Trial version.
Now, to find out the equation, what we do, we consider the axis of the parabola as the x-axis,
Trial version.
and we take the origin at the vertex. So we draw a line through the vertex perpendicular to the axis, and that is the y-axis.
Trial
So
version.
you can see the x-axis and y-axis here, because we have chosen the reference frame in such a way that the axis of the parabola is along the x-axis,
Trial version.
the vertex is at the origin, and the line through the origin perpendicular to the x-axis, that is the y-axis.
Trial version.
And according to our assumption now that the distance between vertex and the focus is A, the coordinates of the focus is A, 0.
Trial version.
I hope it is clear to you. And the equation of this directrix, which is a line parallel to the y-axis, at a distance A units to the left of it.
Trial version.
So the equation of the directrix is x is equal to minus A. Clear? I hope it is understood. There are 3 more cases.
Trial version.
This is one case. Give this parabola a reflection in the y-axis. Reflect this parabola in the y-axis.
Trial version.
Then you get a new orientation of this parabola. This is second case. The third one is
Trial version.
This is I'm sorry. This is the third case. Here is the vertex. This is the fourth case. So there
Trial
are
version.
4 standard forms of parabola. 4 standard forms. Concave to the right, concave to the left,
Trial version.
then concave upwards, concave downwards. But in all the 4 cases, the vertex is at the origin.
Trial
Clear?
version.
Now let us try to
Trial version.
let's try to derive the equation of this parabola now. So now we have understood that the focus is at the point a comma 0 and the directrix is the line x equal to minus a.
Trial version.
Let us take any point P on the parabola whose coordinates with respect to these coordinate axes that we have just chosen.
Trial version.
The coordinates of the point P are x comma y. Fine. Then the point P has coordinates x comma y and the focus F has
Trial
coordinates
version.
a comma 0. What is the distance between the point P and the focus? Use the distance formula. It is root over x minus a whole
Trial
square
version.
plus y minus 0 whole square. That is root over x minus a whole square plus y square. And what is the perpendicular distance of the point P from the line x equal to minus
Trial
a?
version.
What is the distance? You see this distance between the y-axis and the directrix, this is a units.
Trial version.
And between the y-axis and the point, this is x units. So it is x plus a. Total distance x plus a. Or if you consider this point,
Trial version.
the foot of the perpendicular, which is at minus a comma y, and the point P, and use the distance formula, then also you get root over x plus a whole
Trial
square.
version.
That is x plus a only. Anyway, so we know the distance from the fixed point and the distance from the fixed line.
Trial version.
PF and PB. Equate them. So here is PF and here is PB. As I said just now,
Trial
equate them
version.
and square both sides. When you square both sides, the square roots are removed. So removing the square roots, we get x minus a
Trial
whole square
version.
plus y square is equal to x plus a whole square. Simplify it and you get the equation y squared is equal to
Trial
4ax.
version.
This is the standard form, first standard form of parabola. Y squared equal to 4ax, where a is positive.
Trial version.
Any question here up to this? Up to the equation of parabola. What is a, how the equation was derived,
Trial version.
or any name of any part of the parabola? Yes.
Sir, can you hold up 1 second?
Which one?
Trial version.
So the figure 11.16.
Okay, okay. Okay.
Trial version.
Yes, sir.
Okay.
Trial version.
How are these two parabolas related? I'll take you
Trial
to the
version.
diagram once again. Say this parabola. I don't want this. I don't want this. So I take another
Trial
parabola.
version. Trial version.
How are they related? Look at the diagram.
Trial version.
You can see that the second one, y square equal to minus 4x, it is a reflection of the first parabola, y square equal to plus 4x,
Trial version.
in the line, in the y-axis. So if there's a point x comma y on the first parabola, what is the corresponding point on the second parabola?
Trial version.
Its image. If there's a point x comma y on the first parabola, what will be its image in the second parabola?
Trial version.
I mean, when a point x comma y is reflected in the y-axis,
minus x comma y.
minus x comma y. So isn't it
version.
obvious that by replacing x with minus x, we get the equation of this parabola? That is, if the equation of this parabola is y square equal to 4ax,
Trial version.
then the equation of this parabola will be y square equal to 4a into minus x. Because for every point x comma y on the first parabola,
Trial
there's a
version.
corresponding point minus x comma y on the second parabola. So by replacing x with minus x, we get the equation. So the equation of this parabola is y square equal
Trial
to
version.
minus 4ax. Therefore,
Trial version. Trial
yes.
version.
Therefore, the equation of this parabola is y square equal to minus 4ax. And if you interchange x and y,
Trial version.
we get the third diagram. This one. The equation is x square equal to
Trial version.
4ay. Look, the vertex is always at the origin. And when you reflect this in the x-axis,
Trial version.
in which case the point x comma y will be at the point x comma minus y. That is, by replacing
version.
y with minus y in the equation, we get the equation of this parabola, fourth parabola, x square equal to minus 4ay.
Trial version.
Okay. So y square equal to 4ax for this one, y square equal to 4ax, y square equal to minus 4ax,
Trial version.
x square equal to 4ay, x square equal to minus 4ay. Write down the details.
Trial version.
Details means vertex 0, 0, focus a0, equation of directrix
Trial version.
x equal to minus a. And if the equation is y square equal to 4ax, I'm drawing a line. I told you that there's a line,
Trial version.
a focal chord, which is perpendicular to the axis. So now I'm drawing that line.
Trial version.
Suppose this point
Trial
is
version.
L.
So that means lattice rectum is 4a.
Yes, very good. I was about to ask you this question. What is the length of
Trial
this?
version.
L rest. Can you tell me why it is 4a? The equation is y square equal to 4ax. Okay. The abscissa of the
Trial
point L or L prime. Abscissa is a. Now if I put x equal to a in the equation, what do I get? Y squared is equal to 4a into
Trial
a.
version.
That is y square equal to 4a square. So y is equal to plus minus 2a.
Yes.
Y is equal to plus 2a for this point L, and y is equal to
Trial
minus
version.
2a for this point L prime. So the coordinates of L are, what will be the coordinates?
Trial
A,
version.
A comma 2a.
A comma 2a. A comma 2a and a comma minus 2a.
Yes.
This is a comma 2a.
Trial version.
Endpoints of lattice rectum. This is a comma
Trial version.
minus 2a. Endpoints of a lattice rectum. This part, this length is 2a. Very
Trial
important.
version.
Remember, note it down. This is 2a,
Trial version.
and this is also 2a.
Trial version.
Total length 4a.
Trial version.
lattice rectum. So the focus directrix, length of lattice rectum 4a, endpoints of lattice rectum a comma 2a and a comma minus 2a, axis of the parabola x-axis, that is y is equal to 0. What is the equation? Y is equal to
Trial
0.
version.
This is the equation of the axis,
Yes.
which is actually the x-axis, and the equation of the tangent to the parabola at the origin. Tangent to the parabola
Trial
at the
version.
origin. It is the y-axis, that is x equal to 0.
Trial version.
So can you tell me the same thing for this parabola? When the equation is y square equal to minus 4x, number 1, vertex 0, 0.
Trial
Number 2,
version.
focus minus a0. Number 3, equation of directrix, x is equal to plus a. Number 4, length of lattice rectum,
Trial version.
4a. Number 5, endpoints of lattice rectum, minus a comma 2a and minus a comma minus 2a. Number 6,
Trial version.
axis, x-axis, y equal to 0.
Yes.
Then the tangent to the parabola at the origin, at the vertex, y-axis,
Trial
that
version.
is x equal to 0.
Yes.
If we write these in a tabular form for these 4 parabolas, y square equal to
Trial version.
4x, y square equal to minus 4x, and the other 2. X square equal to 4ay, x square equal to minus 4ay. Okay.
Trial version.
All the points that I discussed just now in a tabular form. Look,
Trial version.
main facts about the parabola. Forms of parabolas, y square equal to 4x, y square equal to minus 4x, x square equal to 4ay, x square equal to minus 4ay.
Trial
Note
version.
down these points. Now I hope you'll understand. Can you follow
Trial
this now?
version.
If you want me to repeat any of this
Yes.
or explain any of this, I will do that.
Trial version. Trial
If you have
version.
any questions so far, feel free to ask. Because this concept must be very, very clear.
Trial version.
We're in a very interesting and very important chapter.
Trial version.
So in physics, you must have come across application of these parabolas in projectile motion.
Yes.
You have
Trial
done that.
version.
Concave downwards parabola.
Trial version.
Noted. Any questions?
Trial version.
Can we move on to problems now?
Yes.
Okay. So no doubts, no questions so far?
Trial version.
Very good. So the equations that I'm going to give you now are of this type.
Trial version.
See, from the equation also you have some idea. Y square equal to 4x or y square equal to minus 4x. When you see the quadratic term in
Trial
y,
version.
okay, that means by replacing y with minus y, there is no change in the equation.
No, sir.
Isn't it?
Trial version.
That means this curve is symmetric about the x-axis. So the equation will tell you
Trial version.
if by replacing y with minus y there is no change in the equation, that means the curve is symmetric about not the y-axis but the
Trial
x-axis.
version.
Similarly, by changing x with minus x, by replacing x with minus x, if there is no change in the equation, that means the curve is symmetric
Trial
about the
version.
not x-axis but y-axis. And where did you see that? Come again, please.
Trial version.
Sorry.
Not clear. Voice is getting cracked.
Told us, I mean,
Trial version.
Not clear. Not getting it. See, in case of circles, you see that the equation, when the equation is x squared plus y squared is equal to a squared. I hope you
Trial
remember.
version.
X squared plus y squared is equal to a squared. Did you notice that it is symmetric about the x-axis as well as y-axis? And that is because by replacing x with minus x
Trial version.
or y with minus y, there is no change in the equation. So this helps out. This helps us in tracing a curve.
Trial version.
I'll discuss at length later how to trace a curve, getting a rough idea about a curve. So I'll take the sums.
Trial version.
I think yes. So find the length of lattice rectum
Trial
in each of the
version.
following parabolas. Y square equal to 8x. First one. This equation is similar
Trial
to y
version.
square equal to 4ax. So in case of y square equal to 4ax, what is the length of the lattice rectum? It is 4a. That is
Trial version.
the coefficient of x. The numerical coefficient of x is the length of lattice rectum. That is 4a and that is lattice rectum. So by comparing y square equal to 8x to y square equal to 4ax, we see 4a is equal to 8. So the length of lattice rectum is 8 units. Clear?
Trial version.
Similarly, in part 2, y square equal to minus 12x. How does it look like?
Trial version.
The type 2 parabola. Standard type 2. That is concave to the left. Inverted C-type parabola.
Trial version.
Here the coefficient of x is 12. I mean, numerical coefficient is 12. This is comparable with y square equal to minus 4ax.
Trial version.
Y square equal to minus 12x. This is comparable with y square equal to minus 4ax. Which one? This is the
Trial
one.
version.
Y square equal to minus 4ax. This 4a, this coefficient of x, you see, this coefficient of x
Trial
is the
version.
length of the lattice rectum, this 4a. Everywhere. Y square equal to 4ax, the coefficient, sorry, the
Trial
coefficient
version.
of x, the numerical coefficient of x is the length of the lattice rectum. And 1/4 of this coefficient,
Trial
A,
version.
that is the distance between vertex and focus, or distance between vertex and directrix. Okay?
Trial version.
Coefficient of x, when the left hand side is y square or x square. When the left hand side is y square, the coefficient of x,
Trial version.
absolute value of the coefficient of x is the length of the lattice rectum. And when you divide this by 4 and you get the value of a, that
Trial
is the
version.
distance between the vertex and the focus, or vertex and the lattice rectum. Clear? So you go back to the
Trial
sum.
version.
It was y square equal to minus 12x. So if y square is equal to minus 12x, if y square
Trial version.
is equal to minus 12x,
Trial version.
you can see that 4a is equal to 12. 4a is equal to 12. And that is the
Trial
length
version.
of the lattice rectum. 12 units. That means this part, if I draw the line, that is 12 units.
Trial version.
So in this case, if I draw the line here, then
Trial
this will be
version.
6 and this part will be 6. If it is y square equal to minus 12x. I hope I'm clear
Trial
to you.
version.
yes.
So Part 3. X square equal to 16y.
Trial version.
Compare with x square equal to 4ay. Coefficient of y is that is 16. So 4a equal to 16. That is the length of lattice
Trial
rectum, 16
version.
units. X square equal to minus 10y. Coefficient of y, absolute value of the coefficient of y, 10. So 4a is equal to 10. That is the
Trial
length of the
version.
lattice rectum. But in the fifth case, it is 3y square equal to minus 8x. Not in the standard form. To put it in the standard form, we must divide both sides
Trial
by the
version.
coefficient of y square. So divide by 3 and you get y square equal to minus 8 upon 3x. Now look at the coefficient of x. Minus
Trial
8 upon
version.
3. Absolute value 8 upon 3. That is the length of the lattice rectum. That is 4a. So 4a is equal to 8 upon 3. And that is the
Trial
length of the LR. We'll call it LR. Lattice rectum. So this is clear, I suppose. Next type. Find the coordinates of the
version.
focus of each of the following parabolas. Coordinates of the focus. You see, all the four equations are in standard forms. Standard
Trial
form, type 1, this is type 2, this is type 3, this is type 4. All arranged in order.
Trial version.
So now we have to find out the focus. In type 1, where is the focus? A comma 0. What is A? The coefficient
Trial
of x
version.
will give you 4a. So 4a is 12. Therefore, a is 3. Therefore, where is the focus? 3 comma 0.
Trial version.
Are you getting it? If you have any doubt, tell me. You have to stop me. I'll explain on again. This is type
Trial
1,
version.
C-type parabola. 4a equal to 12, a is equal to 3. Focus is at a comma 0, so the focus is at 3 comma 0. If this is the case, this is
Trial
type 2,
version.
that is inverted C-type parabola. 4a is 8, a is 2. Where is the focus? Minus a comma 0. So minus 2 comma
Trial
0.
version.
This is type 3, 4a is 16, a is 4. Where is the focus? 0 comma a, 0 comma 4. In this case,
Trial version.
fourth case,
0, minus 9 by 4.
correct.
Trial version.
So here are the answers.
Trial version. Trial version.
But unless I get more and more questions from your side, I'm not too sure about how,
Trial version.
whether you're understanding, whether you're following it or not. When you ask questions, then I'm sure that yes, you're following it.
Yes, understood.
But when you keep quiet, I have no clue.
Trial version.
So for type 4. And you all said correctly.
Trial
And I'll
version.
request all of you to participate. Tell me answers. Maybe wrong, maybe right, no problem. This is a type, it's a very common type.
Trial
That
version.
is when the focus is given and the direction is given, and you have to find out the equation of the parabola. In such cases, we have to use the definition of parabola. What is the
Trial
definition?
version.
That PS upon PM is equal to E is equal to 1. That is PS upon PM is equal to 1. We begin with a point P,
Trial
coordinates
version.
x comma y. S is the focus. This is the directrix. Now clearly the directrix is not parallel to any coordinate axis.
Trial version.
It is an inclined straight line. X plus y is equal to, this is an inclined straight line. But you have to find out the equation.
Trial version.
To find the equation of the parabola, we use the definition PS upon PM is equal to 1. That is PS is equal to PM. Now
Trial
follow these
version.
steps. The focus of the parabola is at S 3 comma minus 4. And the directrix is the line x plus y minus 2 equal to
Trial
0.
version.
Let Px comma y be any point on the parabola. And let PM be the perpendicular distance
Trial
from
version.
P to the directrix, then by definition, PS equal to PM. What is PS?
Trial
PS
version.
is simply the distance between the 2 points P and S. P that is x comma y, S that is 3 comma minus 4, and PS therefore square root of
Trial version.
x minus 3 whole square plus y plus 4 whole square. Now what is PM? PM is the perpendicular distance
Trial
of the
version.
point x comma y from the straight line x plus y minus 2 equal to 0. What is the formula? Try to recall. In straight line, the chapter
Trial
straight
version.
line,
X
we
plus
learned
by
that right. The distance of the point x1 comma y1 from a straight line
Trial
ax
version.
plus by plus c equal to 0. The perpendicular distance of the point x1 comma y1 from the straight line ax plus by plus c
Trial
is equal to
version.
0 is ax1 plus by1 plus c divided by square root of
Root
a
of a
square
square.
plus b square,
Trial version.
and the absolute value of this. Using that formula, the distance of the point px comma y from this straight line,
Trial
x1 is
version.
x, y1 is y. So pm will be x plus y minus 2 divided by square root of a square, that is 1 square, plus b
Trial
square,
version.
that is again 1 square. Is it okay? Understood? Yeah, you may put
Yes,
this
sir.
within
Trial version.
modulus. Yes.
Trial version.
Now just simplify and you get the answer. To simplify, we square both sides and
Trial
expand
version.
and simplify, and finally we get the answer. This is the locus of the point. This is the equation of that parabola.
Trial version.
Not in the known form, isn't it? It is none of those 4 types that we learned just now. We learned only y square
Trial
equal to 4ax or minus 4x, or x square equal to 4ay or minus 4ay. And now we see that the equation is totally something different.
Trial
Why is it
version.
so? Can you tell me why? It is the equation of a parabola, but it is none of those 4 types. Why is it so?
Trial version.
Because that one was the standard equation which follows the axis as x-axis and the
Correct.
Trial
directrix
version.
is perpendicular to y-axis.
Correct. Very good.
Right line.
The ones we learned just now, they are special cases.
Trial version.
In those cases, the axis is along the x-axis or along the y-axis. Vertex is at the origin. So they are special cases.
Trial
In
version.
general, the vertex is not supposed to be at the origin. The directrix or the axis is not supposed to be along the x-axis or along the
Trial
y-axis. It can be anywhere. The parabola can be anywhere. The vertex can be anywhere. The axis of the parabola can be inclined at any angle
Trial version.
with the x-axis. That is a general form. So this is one of those types. Neither the vertex is at the origin, nor the axis
Trial
of this
version.
parabola parallel to x-axis or y-axis. And that is the reason we get such an equation. Now, if you notice,
Trial
if you look at
version.
this equation, just a bit off the topic parabola, you see that there are
Trial version.
second degree terms, x square, xy, y square. Then there are linear terms, x, y, and there is
Trial
also
version.
constant term. If we generalize this equation, this is called a general second degree equation.
Trial
Which
version.
equation? Ax square plus 2hxy plus by square plus 2gx plus 2fy
Trial
plus
version.
c equal to 0. This equation in general represents any of those conic sections, whether it is a
Trial
circle
version.
or parabola or ellipse or hyperbola or a pair of straight lines. They're all of this type, a general second degree equation.
Trial version.
And there's a way to identify the type simply by looking at the equation. Simply by doing
version.
some calculations, we can figure out whether it is a parabola or ellipse or hyperbola or a circle or a pair of straight lines.
Trial version.
Just looking at the equation. Suppose you are given the equation of this curve, like the final one. One such equation
Trial
is given to
version.
you. And you'll be asked to identify what type of curve is this. Parabola, ellipse, hyperbola, circle,
Trial
pair
version.
of straight lines. And you can do it. So we'll do that later, not now. Identification of the
Trial
curve,
version.
conic sections. We'll do that later. Now, the next question is, in each of the cases, find the lengths
Trial
of the
version.
lattice rectum, the coordinates of focus, and the equation of directrix. Can you tell me?
Trial version.
Yes, sir.
First one. What is? I'll ask you, then you tell me the answer. Okay.
Trial version.
Which type is this? Type 1, 2, 3, 4. Which type is this?
Type 1.
Type 1. Where is the vertex?
Trial version.
0,0.
What is the value of 4a?
2 root 3.
So what is the value of a?
Root 3 by 2.
Trial version.
So where is the focus?
Root 3 by 2,0.
What is the length of the lattice rectum?
2 root 3.
Trial version.
Good. And what is the equation of the directrix?
X equal to minus 2 root 3. X equal
Trial
to
version.
minus root 3 by 2.
Very good. So I hope all of you have understood. If any one of you have any question or doubt,
Trial version.
ask me. This is how we will write. Y square equal to 2 root 3x, which implies 4a equal to 2 root 3. So a is equal to root 3 by 2.
Trial version.
Length of the lattice rectum, always 4a. That is 2 root 3 units. Coordinates of
Trial
focus,
version.
a comma 0. That is why it is root 3 by 2 comma 0. Equation of directrix, x plus a equal to 0. That is x plus
Trial
root 3 by 2 equal to 0. That is 2x plus root 3 equal to 0. Will someone else try to solve part 2 now?
Trial version.
Anyone?
Yes, sir.
Tell me in order. Lattice rectum,
Trial version.
focus, directrix. Part 2.
So the
Right.
lattice rectum is 4.
Correct?
Trial version.
The coordinates of the focus are minus 4, 0.
Minus 4 comma 0 is wrong.
Trial version.
Try again.
Minus 1,0.
Minus 1 comma 0. Correct. Equation of directrix.
Trial version.
X equal to 1.
X equal to 1. Very good. Okay. So part 2 is done.
Trial version.
Part 3. Will someone try? Though the answer is not here. But
Trial
I'll tell you.
version.
Will someone try? Part 3.
Trial version.
Anyone?
Trial version.
No one else is showing any interest. Fine, go ahead. So I'll carry on.
Trial version.
Number 5. Then find the coordinates of the point on the
Trial
parabola
version.
whose ordinate is equal to 3 times the abscissa. Find a point on the parabola whose ordinate is 3
Trial
times the
version.
abscissa. Ordinate, that is the value of y. Abscissa, that is x. You have to find a point on this curve where
Trial
the
version.
value of y is 3 times the value of x. How do you do it? Let us assume
Trial
the
version.
abscissa h. Then the ordinate, according to this condition,
Trial version.
the
Sure.
ordinate will be 3h. Yes,
Sir, is it 2,6?
it is
Trial
2,6. So how do you get it? Let the abscissa be h,
Trial
therefore the
version.
ordinate is 3h. Therefore the point h, 3h lies on this parabola.
Trial version.
Substitute. Put x equal to h, y equal to 3h. And you get the
Trial
equation
version.
9h squared is equal to 18h. From which we get two values of h. One
Trial
is
version.
0, the other one is 2. So one point is obviously 0, 0.
Trial version.
And the other one is h is 2. Therefore, k, I mean
Trial version.
the ordinate is 3 into 2, that is 6. So the point is
Trial
0, 0
version.
or 2, 6. Next question.
Trial version.
If the parabola y square equal to 4px passes through the point 3, minus 2, then find the
Trial
length of
version.
the LR and the coordinates of the focus. This
Trial
parabola
version.
passes through the point 3, minus 2. Substitute. Put x equal to
Trial
3
version.
and y equal to minus 2. Fine.
Trial version.
When you do that, what is the value of p? What is the value of p?
Trial version.
Put x equal to 3, y equal to minus 2. Find p.
Trial version.
So 1 by 3.
Yes, p is 1 by 3.
Trial version.
That means the equation of the parabola is y squared is equal to 4 by 3x.
Means length
Y
of
squared
the-
equal to
version.
4 by 3x. Yes. Length of the system is 4 by 3.
and,
Because the equation is
Trial version.
the focus is 1 by 3, 0.
correct. Because p is equal to 1 by 3,
Trial
the
version.
equation is y squared equal to 4 into 1 by 3, that is 4 by 3. Y squared equal to 4 by
Trial
3x. Coefficient of x, 4 by 3. That is the length of LR.
Trial version.
So the length of letter term is 4 by 3 units.
Trial version.
And because a is equal to 1 by 3,
Trial
the
version.
focus is at a, 0. That is 1 by 3, 0. Take it down.
Trial version. 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 Trial version.
All right, next one.
Trial
Find the
version.
equations of the parabolas with vertices at the origin and satisfying the
version.
following conditions. Vertex always at the origin. First condition,
Trial version.
focus is at minus 4, 0. Second condition,
Trial
this is
version.
for a second, another parabola. Directrix is y minus 2 equal to 0. And for another
Trial
parabola,
version.
the parabola passes through 2, 3. And the axis of the parabola is
Trial
along the
version.
x-axis. There are 3 different parabolas. Get the equations one by
Trial
one.
version.
First, number 1. Vertex at the origin and focus at minus 4,
Trial
0.
version.
Which type is this?
Second type.
Second type.
Trial version.
So the equation is of the type y squared equal to minus 4ax
Trial version.
What is A in this case?
4.
4.
Trial
So y
version.
square equal to minus 16x.
Correct.
Trial
So the focus
version.
minus 4 comma 0 lies on the x-axis and the vertex is at 0 0. So the parabola is of the form y square equal to minus 4x, where A is equal to 4, because
Trial
A
version.
is the distance between the vertex and the focus.
Trial version.
Therefore, the equation of the parabola is y squared is equal to minus 16x.
Trial version.
Now part 2.
Trial version.
Part 2, what is the condition? First you note it down
Trial version.
and try part 2.
Trial version.
So can I show the question once?
Mhm.
Trial version.
Directrix is y minus 2 equal to 0.
Trial version.
That is y equal to 2.
So y square equal to
That
minus
is
16.
Trial version.
y square equal to minus,
8x.
Trial version.
correct. You see the directrix is a line parallel to
Trial
x-axis
version.
2 units above the origin. A line parallel to x-axis
Trial version.
2 units above the origin. So the distance between the line, the
Trial
directrix, and the vertex is 2 units, and therefore
Trial
A
version.
is 2. And so the focus is
Trial
on the
version.
y-axis 2 units below the origin. So the focus is
Trial
at 0,
version.
comma minus 2. The equation is, because A is equal
Trial
to 2,
version.
and the equation
Trial
x square
version.
equal to minus 4ay,
Trial version.
x square equal to minus 8y, or x square plus 8y equal to 0.
Trial version.
The directrix is y minus 2 equal to 0, which is a line parallel to the x-axis, and the
Trial
vertex
version.
is at 0 0. So the parabola is of the form x square equal to minus 4ay,
Trial
where
version.
a is 2. 2, that is the distance between the vertex and the
Trial
directrix.
version.
So the equation is x square equal to minus
Trial
8y,
version.
because a is 2, or x square plus 8y is equal to 0.
Trial version.
Okay, understood?
Trial version.
Yes, sir.
Part 3. Now the
Trial version.
parabola passes to the point 2 comma 3, and the
Trial
axis
version.
of the parabola is along the x-axis. If the
Trial
axis
version.
is along the x-axis and the parabola passes to the point 2 comma 3, is it type
Trial
1
version.
or type 2?
Type 1.
Type 1, because the
Trial
point is in
version.
the first quadrant. Type 2 parabola, it passes through the second
Trial
quadrant
version.
and third quadrant, not in the first quadrant.
Trial
So
version.
we may take the equation of the parabola y square equal to 4ax and substitute
Trial
x equal to
version.
2 and y equal to 3 to find out a. Y square equal to 4ax,
Trial version.
x equal to 2, y equal to 3.
So 2y square equal to 9x.
Trial version. 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 Trial version.
Next question.
Trial version.
Find the vertex, focus, length of letter system,
Trial
equation of
version.
axis, directrix of the parabola. First copy the
Trial
question, then
version.
I'll explain.
Trial version. 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 Trial version.
So I hope you have copied the
Trial
question.
version.
Now look at this.
Trial version.
Now the vertex is no
Trial
longer at
version.
the origin. Vertex is elsewhere.
Trial version. Trial version.
Y-axis,
Trial version. Trial version.
x-axis. But the parabola is
Trial
somewhere
version.
else.
Trial version. Trial version. Trial version. Trial version. Trial version.
Suppose this is a parabola.
Trial
The
version.
vertex is here.
Trial version.
This is the vertex.
Trial version.
Suppose the vertex is at the point
Trial
h comma
version.
k.
Trial version. Trial version. Trial version. Trial version.
Excuse me.
Trial version.
And the focus is here.
Trial version.
Here is the focus.
Trial version.
And the directrix.
Trial version. Trial version.
This is the directrix.
Trial
What is the
version.
equation of this parabola? How do you know?
Trial
To
version.
know the equation,
Trial version.
we need to know the distance between vertex
Trial
and
version.
focus. Suppose the distance is a.
Trial version.
Suppose this distance
Trial version. Trial version.
is a.
Trial version.
Can you find the equation now?
Trial version.
Think and tell me.
Trial
Vertex is
version.
at a. How do you find out the equation of this parabola?
Trial version.
To find out the equation, we
Trial
draw
version.
another set of coordinate axes. Suppose we shift the origin
version.
from this point O to the
Trial
point A,
version.
whose coordinates are HK. So we define a new x-axis,
version.
new y-axis. The original x-axis is this is x.
Trial version.
Watch very closely.
Trial
Important
version.
concept I'm going to give you. Original y-axis.
version.
Okay. To understand this equation, to find out the equation of this parabola,
Trial version.
we define a new x-axis and new y-axis.
Trial version. Trial version. Trial
This is our
version.
new x-axis. That is a line
Trial
along
version.
the axis of the parabola. That is a new x-axis. So
Trial
this is the
version.
vertex. Through the vertex, I take another line.
Trial version. Trial version. Trial version.
This is the new y-axis.
Trial version.
So I give it a name.
Trial version.
New x-axis, capital X. New
Trial
y-axis,
version.
capital Y.
Trial version.
Now imagine there's a
Trial
point
version.
P on the parabola.
Trial version.
There's a point P on the parabola.
Trial version.
Whose
Trial
old
version.
coordinates are x comma y.
Trial version. Trial version.
And the new coordinates are capital X, capital Y.
Trial version.
Same point, but new coordinates in
Trial
terms of,
version.
with respect to the new coordinate axis, capital X, capital Y.
Trial version.
To understand the relation between small x, small y and capital X, capital Y,
Trial version.
we drop two perpendiculars.
Trial version. Trial version. Trial version. Trial version.
What is this length?
Trial version. Trial version.
This is H.
Trial version. Trial version. Trial version.
This is capital X.
Trial version.
So this is also capital X.
Trial version. Trial version.
And the total length is small x.
Trial version. Trial version.
Then can we write
Trial version.
small x is equal to
Trial version.
H plus capital X
Trial version.
and similarly small y is equal to
Trial version.
K plus capital Y.
Trial version.
What we are learning is
Trial version.
translation of coordinate axis, shifting the
Trial
coordinate
version.
axis. Is it
Trial
okay?
version.
Have you understood this? Can you follow this?
Yes, sir.
Trial version.
Now, suppose the equation of this parabola, old parabola, in terms of the
Trial
old
version.
coordinate axis, in terms of the new coordinate axis,
Trial version.
capital X, capital Y. See, this is capital X, and
Trial
what is
version.
capital Y? This part is capital Y.
Trial version.
This is capital Y.
Trial version.
So what will be the equation of this parabola? Y square
Trial version.
is equal to
Trial version.
4ax.
Trial version.
This is the equation. In
Trial
terms of the
version.
old coordinate axis, what is the equation then? What is capital
Trial
Y?
version.
Small y minus k
Trial version.
whole square
Trial version.
is
Trial
equal
version.
to 4a.
Trial version.
Capital X is small x minus h.
Trial version. Trial version.
This is the equation of this parabola.
Trial version.
Where is the vertex?
Trial version. Trial version. Trial version.
Vertex means x0, y0. X equal to 0,
Trial version.
y equal to 0.
Trial version.
Because the vertex is at 0, 0. That means
Trial version.
x minus h equal to 0, y minus k equal to 0. H comma k.
Trial version. Trial version.
Vertex is at h comma k. Where is the focus?
Trial version.
In
Trial
terms of the
version.
new coordinate axis, the focus is at a comma 0, but capital X equal to
Trial
a
version.
and capital Y equal to
Trial
0.
version. Trial version.
Capital X equal to a, that means x minus h.
Trial version.
Capital X is small x minus h. So x minus h is equal to a
Trial version. Trial
and
version.
y minus k equal to 0.
Trial version. Trial version.
That means you may say the focus is at
Trial version.
h plus a
Trial version.
comma k.
Trial version.
If you compare with the original
version.
formula, originally the formula was a comma 0. Here the
Trial
formula
version.
is h plus a comma k plus 0. Do you notice that we are actually adding
Trial
h
version.
and k to the coordinates? A comma
Trial
0 has
version.
become h plus a comma k plus 0. Had the origin been
Trial
here at
version.
a, the focus would have been a comma 0.
Trial
But
version.
because the origin is elsewhere, because the vertex is at the point h comma k,
Trial
we are
version.
adding h to the x coordinate and k to the y coordinate.
Trial version.
So how do we get all these without going through all these things, all the diagrams and
Trial
everything?
version.
How do I get everything in quickly at once?
Trial
Had the
version.
origin been here at the vertex, the equation would have been y square equal to
Trial
4ax.
version.
If the vertex is at some other point, replace y with y
Trial
minus
version.
k, replace x with x minus h. And to get the
Trial
coordinates to the original coordinates, you add h to the x
Trial
coordinate,
version.
k to the y coordinate. So the rule is simple. Replacing
Trial
x
version.
with x minus h
Trial version.
and k with y minus k.
Trial version.
Replacing y with y
Trial
minus k.
version.
You get the equations. That is number 1.
Trial version.
And for the coordinates, add
Trial version. Trial version.
h to
Trial version.
x coordinate
Trial version. Trial version.
and add k to
Trial version.
y coordinate.
Trial version. Trial version.
Simple rule.
Trial version.
Now if I give you another parabola, say for example,
Trial version.
So to find the length of lattice rectum, what will we do?
Trial
that will be
version.
the coefficient of this x minus h. That constant, that coefficient will be the, let's
Trial version.
Okay, man, it's 4D.
the coefficient of x or the coefficient
Trial
of y,
version.
the linear term.
Okay, sir.
Okay, suppose there's a parabola here.
Trial version. Trial
Whose
version.
vertex is at, say,
Trial version.
vertex at alpha beta.
Trial version. Trial version.
And suppose the distance between vertex and focus is still same, a.
Trial version.
This is a, suppose. Can you tell me
Trial
quickly
version.
what is the equation of this parabola? Very quick.
Trial version.
Imagine the origin is here. Then what
Trial version.
what would have been the equation? Imagine the axis at the
Trial version.
axis as the x-axis, and the origin is at the vertex.
Trial version.
Then the equation would have been y square equal to minus 4ax.
Trial version.
Now replace y with y minus beta and x with x minus alpha. Now tell me what is the
Trial
equation.
version.
Y minus
Trial version.
beta whole square,
The whole square.
that is y square,
Trial version.
is equal to minus 4a
Minus 4D.
Trial version.
X minus
minus 4a, not x but x minus
X minus alpha.
alpha.
Trial version.
Are you getting the idea now? How
Yes.
quickly you can get the equation?
Trial version.
Similarly, it can be like
Trial version.
this. It can be like this. Okay.
Trial version.
Imagine what the equation would have been at the origin
Trial
being at the
version.
vertex. And had the axis been
Trial
one of the
version.
coordinate axes. Accordingly, you will replace x with x minus h and y with y minus k, you get the
Trial
equation.
version.
Fine. So now I go back to that sum.
Trial version.
Now you are in a position to solve it. Where is my file?
Trial version.
Here. So this is the equation.
Trial version.
Clearly, the equation is not one of those four standard forms.
Trial version.
Y square equal to 4x, y is equal to minus 4x. Not of this type. Because you can see it already
version.
x is there or y is there. Looking at the quadratic term, y square,
Trial version.
linear term is x, quadratic term in y.
Trial
It is
version.
clear that the type will be y minus beta whole square is equal to
Trial
plus
version.
minus 4a into x minus alpha. Y minus k whole square is equal to plus minus 4
Trial
into x
version.
minus h. That is the type. So we'll move towards that direction.
Trial
Let us take
version.
y together, y square minus 8y, and take the terms to the other side.
Trial version.
And y square minus 8y, let us make it a whole square. To make this a
Trial
perfect
version.
square, we add 16. Only then we can make it a perfect square. So
Trial version.
this was plus 19. I keep 16 here. So minus 3 on the other
Trial
side.
version.
Plus 19, balanced. This implies y minus 4
Trial
whole square
version.
is equal to x minus 3. X minus 3, that is 4 into 1/4
Trial
into x
version.
minus 3. I mean 4a is 1. So I put it in
Trial
that form,
version.
4 into 1 by 4. Just to put it in the form 4a into x minus 3.
Trial
So I
version.
can understand that a is 1/4. Now shifting the origin to the point 3,
Trial
4.
version.
Y 3, 4, x minus 3, y minus 4. Equating this to 0, you get x equal to
Trial
3.
version.
Equating this to 0, you get y equal to 4. That means one thing is clear, that vertex is at 3/4.
Trial version.
Shifting the origin to the point 3/4, the new axis, that is
Trial
capital X,
version.
capital Y, remaining parallel to the original coordinate axis, we get the equation of the
Trial
type
version.
y square equal to 4 into 1/4 into x, where
Trial
capital X
version.
equal to x minus 3 and capital Y is y minus 4.
Trial
A is
version.
1/4. So how do you get the vertex? Vertex is given
Trial
by
version.
x equal to 0, y equal to 0. That is x minus 3 equal to 0, y minus 4 equal
Trial
to 0.
version.
That is x equal to 3, y equal to 4. The vertex is at 3, 4.
Trial version.
Any doubt here? How to find the vertex?
Trial
Is it okay?
version.
Yes, sir.
Now, what is the next thing?
Trial
Focus.
version.
In terms of capital X, capital Y, where is the focus?
Trial
A comma
version.
0 means capital X equal to A, capital Y equal to 0.
Trial version.
So the focus is given by capital X equal to A, capital Y equal to 0. But capital X
Trial
means
version.
small x minus 3. So x minus 3 equal to A. A means 1/4.
Trial version.
And capital Y is y minus 4. That is 0.
Trial version.
And we get the focus
13 by 4,
13 by 4,
Trial
4.
version.
Length of LR. Here you can see 4a equal to
version.
1. So length of LR is
1 unit.
that is 1 unit. That is simple.
Trial version.
Equation of the axis y equal to 0.
Trial
Capital Y
version.
equal to 0. But capital Y is small y minus 4. So y minus 4 equal to 0.
Trial version.
Equation of the directrix. Capital X plus A equal to 0.
Trial version.
But capital X is small x minus 3. So x minus 3 plus 1/4 is
Trial
equal to 0.
version.
That is this. And you have
Trial
found
version.
everything that was asked.
Trial version.
Clear?
Yes, sir.
Trial version.
So another similar application.
Trial version.
I kept it for you to do it. Find the vertex,
Trial
focus,
version.
length of failure, equation of axis, everything like this for this parabola.
Trial version.
So which is the quadratic term here? X. We have x squared.
Trial
That means
version.
we have to put it in the form x minus h whole squared is equal to plus minus 4a
Trial
into y
version.
minus k. X minus h whole square. So we
Trial
take x
version.
terms together. X square minus 3x together. If we do
Trial
that,
version.
we get x minus 3 by 2 whole
Trial
square
version.
is equal to minus 2y minus 5 plus 9 by 4,
Trial version.
which simplifies to x minus 3 by 2 whole square is equal to minus 2
version.
bracket y plus 11 upon 8. If you
Trial
compare
version.
the standard forms, by replacing x minus
Trial
3 by 2
version.
with capital X and y plus 11 upon 8 with capital Y,
Trial version.
which type is this? Capital X squared equal to minus 2 capital Y.
Trial version.
It's like x squared equal to minus 4ay. That is the type.
Trial version.
X squared equal to minus 4ay, that is type 4.
Trial version.
Now if you find out the vertex,
Trial
focus,
version.
you can do it, I suppose. Similar to that previous one.
Trial version.
Try it. I take one
Trial
more problem,
version.
another application, because we don't have much time left.
Trial version.
Find the equation of this parabola whose vertex is at 4, 1 and
Trial
focus
version.
at 4, minus 3. Imagine
Trial
there are
version.
2 points, 4, 1, 4, minus 3.
Trial
So
version.
again you have to go back to the diagram. Vertex 4, 1,
Trial
focus 4, minus 3. Remember,
Trial version. Trial version. Trial
y-axis,
version.
x-axis,
Trial version.
vertex at 4, 1,
Trial version.
vertex at 4, 1, focus at 4, minus
Trial
3.
version.
If I
Trial
draw
version.
the parabola, how will it look like?
Trial version. Trial version.
Somewhat like this.
Trial version.
Yes.
What is this length? That is distance between vertex and
Trial
focus.
version.
This is 4, 1,
Trial version.
4, 1.
Trial version.
This is 4,
2 units.
minus
Trial
3.
version.
What is the distance between vertex
Trial
and focus?
The 4 units.
So A is equal to 4
Trial
units.
version.
Clear?
Trial version.
Can you find the equation now?
Yes.
At once.
Trial version.
Quick. What will be the equation?
Trial version.
I draw another diagram. If the parabola was like this,
Trial version.
sorry. If the parabola was like this,
Trial version.
then the equation
Trial
would have been x squared is
Trial
equal to
version.
minus 4ay type.
Trial version.
So looking at this equation, can you tell me what will be the equation of this parabola?
Trial version.
So what did I teach you? That replace x with x minus
Trial
h.
version.
Yes, sir.
So x minus 4 whole
Trial
square.
version.
In place of x square, you have x minus 4 whole square
Trial version.
is equal to minus 4 into a. What is
Trial
a?
version.
4. What is 4a? 16. So
Trial
minus
version.
16 into, replace y with
Trial version.
y minus 1. So into y minus
Trial
1
version.
is the answer. Am I clear to you?
Trial
Is it
version.
okay? Understood?
Trial
Yes.
version.
Have you all understood? This is the reason
Trial
now you'll
version.
understand quadratic functions better. Once
Trial
you understand
version.
these parabolas, you'll understand the quadratic equations better. Because all those functions,
Trial
quadratic
version.
functions, are actually parabolas. These are
Trial
the
version.
roots. These are the roots of the equation.
Trial version.
If you make y the
Trial
subject, if you make y the subject, it will be like y
Trial version.
equal to fx, which is the
Trial
quadratic in
version.
x. And if you equate that to 0, then the roots
Trial
are alpha,
version.
beta. So
Trial
these are
version.
those roots. These are those roots alpha and beta,
Trial version.
like that.
Trial version.
Anyway. So next week I thought
Trial
I would
version.
start ellipse also today. Any questions from parabola?
Trial version.
Let me teach you two more things quickly.
Trial version.
Y equal to
Trial version.
quadratic in x.
Trial
Y equal
version.
to ax square
Trial version.
plus bx
Trial version.
plus c.
Trial
This
version.
will always represent a parabola whose axis
Trial version.
is parallel to y-axis. So this
Trial
is
version.
like this
Trial
one.
version. Trial version.
Try to. Oh, yes.
Yeah.
Trial version.
If A is positive,
Greater than 0.
Trial version.
and this will be like
Trial version.
this one.
Trial version.
If A is
Trial
negative,
version.
and
Trial version.
x equal to ay
Trial
square
version.
plus by
Trial version.
plus c. That is
Trial
x equal
version.
to quadratic in y. This will be
Trial version.
like this.
Trial version. Trial version.
If A is positive,
Trial version.
it does not mean that it is not cutting the x-axis. It will
Trial
cut the
version.
x-axis if you produce it. It will cut, surely.
Trial
And this
version.
is like
Trial
this.
version.
That is concave left. If
Trial version.
A is negative.
Trial version.
Okay. See, the axis is, in both the cases, axis
Trial
is
version.
parallel to x-axis. You see, the axis is parallel to x-axis, and in these two
Trial
cases,
version.
the axis is parallel to the y-axis.
Trial version. Trial version.
Connected, parabola and quadratic functions. They are
Trial
related.
version.
Okay, so there are many more
Trial
things to
version.
learn from this chapter parabola, but many things are not in the scope of your syllabus now.
Trial version.
So next class we'll start ellipse. You solve the sums from Emil Agarwal
Trial
or any
version.
other textbook on parabola.
Trial version.
Hope there is no other question.
Trial version.
But they are keeping quiet. You're not asking questions. I'm expecting questions. You're not asking.
Trial version.
Anyway, good night, everybody.
connection.
Trial version. Trial version. Trial version. Trial version. Trial version.